Hi, my name is Patrick Smith. I'm implementing CRC algorithm in Orb, which is a compiler or like a DSL for WebAssembly. I spent probably an hour tonight doing this, and it was actually surprisingly easy. So yeah, I just walked through how I implemented this and what exactly CRCs are. So they're checksums, which are used. I believe they come from Ethernet. So when you've got like a signal going over a wire, the wire may have some sort of noise on it, and so you want to make sure that the bytes that you get at the other end are actually what you intended. So you often have like a payload, and you have this little checksum, which is a sort of mathematical summarization of those bytes that get tacked along alongside the packet that is sent. And so it's used in PNG, gzip, and formats that I'm probably more interested in eventually implementing. So here's the code. I'll walk through it soon, but just first, what's Orb? So Orb is lets you write WebAssembly in Elixir, which is a very high-level language. So Orb looks something like this. It kind of looks like Ruby. It's like a cross between Ruby and Elixir and the WebAssembly raw syntax. And so Orb is like a compiler or DSL for WebAssembly, but it's pretty low level, so you often want a bit more. And so I'm writing yet another library. This one's SilverOrb, and so this is what I think of as the standard library for Orb, or maybe the batteries included for Orb. So WebAssembly just gives you like integers and floats and stuff and not much more. So this is what I'm slowly building out here, string operations, basic algorithms, different formats and so forth. So I've got a big list of issues with just sort of all sorts of random ideas. There might be low level, there might be high level, just different algorithms that I think that will be important to have. So something like time zone data is pretty critical. That's a database that I could download and see how much room that takes up. It's often one of those little hidden sort of files that are stored on all of our computers, all of our devices, that has to be kept up to date, but we don't really think about it. So I'm thinking about that sort of stuff, as well as like favicon generators. I so often need to generate a favicon, and so I'm going to try and solve that problem once and for all. And just other sort of formats that I think, this might be down the road a bit. I don't know how complicated all these are, but like audio wave support, bar charts, or just all sorts of ideas. So if you have any other ideas as well, feel free to add an issue in the SilverOrb repository. That's royal/SilverOrb. And can't promise I'll get to them all. This is sort of my to-do list for just stuff that I find interesting. But I'm hoping that I can implement a lightweight version of this in my library that is then going to be portable. So WebAssemblies can be run in the browser, can be run on phones, can be run on like a laptop like this one, can be run in the Vision Pro or whatever other device that may or may not take off, can be run on the server. So it runs everywhere. So back to CRC32 codes. So I was looking at this library. So I had created an issue for I think PNGs and deflate and so forth. So it's sort of like a high level problem. And this is the fantastic thing about open source, is I can look at this little library that's just does solve this one problem really well. So this is a simple library for managing PNG chunks. So PNGs are made out of different chunks that are all sort of stapled together. And so this is just written in C. And so it's also got this it's like sort of opinionated thing where it's not using any third-party libraries. So they call this a single file header only library. And so this is really useful for someone like me because I know this thing's going to be does everything it says, looks, it's just, got 144 stars. It's, been around for a few years. I feel like a lot of this person's put a lot of effort into this project. So if I imagine what it says it does here on the tin is what it's going to is correct if I look at the code. So if I just jump into the code, I just generally love source files with excellent documentation like this. This is one of the things I need to improve with Orb. So feel free, if you look into it, to prompt me to write particular sections to expand on them or what you think is missing. I won't be offended. So yeah, it's just this sort of header stuff, it's saying like literally, memory allocation and some file stuff, but like there's not much here. So this is really useful for someone like me to try and understand the code. So I noticed it had this compute CRC32. So that's like, you can see here, there's going to be chunk, there's going to be how long the chunk is, and then it's got a checksum. So that's how PNG, like it's a critical part of PNG. And so yeah, it's just, if I try and find the actual implementation, here it is. I go to so this is sort of like, what, 30 lines of code. So it's like, okay, this doesn't look too hard. It's a bunch of magic numbers. And then there's a very simple algorithm using that lookup table to do some magic stuff with the magic numbers. But like that's not too hard. So I set a goal for tonight is to try and implement this in Orb. And so Orb's like compiles directly to WebAssembly, doesn't come with anything else. So that's why the single header file stuff's just so it's gold for me, because I'm not going to have any dependencies either, and it's in some ways it's even more harsh because I don't even have a memory allocator. I've got some stuff for like a simple bump allocator, but like you're kind of just writing. It's higher level than CPU assembly code, but it's like there's not really much to go with. And I've been working on this project for over a year, probably close to 15-16 months, so I've gotten sort of used to it. It was a bit of a shock at first, but yeah, like, so I'm wondering, okay, how can I implement this algorithm? And so just googled around. I noticed Zig had some awesome implementations of this stuff. So Zig's another programming language. It's much more little bit higher level, which is sort of surprising. I would call myself a Zig amateur, but it's got nicer features than WebAssembly and Orb, but it's really well implemented. And so you can see they've got like a kitchen sink of all these different other CRCs. There's they're like Pokemon, you got to catch them all. So they've caught them all here, and so they all have this sort of base algorithm of a polynomial and different stuff, different decisions that they've made. And so it looks like you could spend like a week here, just understanding the history and the, which I'm sure there's lots of opinions on which particular CRC is the best. And then if you look at, so this is sort of this declarative thing with a different polynomial, different sort of starting magic number, and that's used to generate the table. So I can see here that that lookup table that was in that header file, all those magic numbers that were here, they're actually generating this on the fly. So I had a look at this and didn't study it too closely, but yeah, okay, there's 256 numbers here, there are 256 here. So yeah, they're generating this on the fly, and looks like you're able to just sort of, the code doesn't look that complicated. And so then I'm wondering, how hard is it to generate this table on the fly? Do I need to hard code 256 different numbers when I'm writing in an Orb? And I'm also kind of wondering, like, the algorithm for it doesn't look that complicated. What happens if instead of stashing it away on a table, I just generate it on the fly as I need it? Is that doing random access lookup into this table, or is it just sort of just walking through? And like from here, it looks like it's just looking at the buffer, and like it doesn't look like it's doing too much. So I found some other implementations. I researched on Stack Overflow like everyone would. I don't even feel like I have fully understood how CRCs work. There's this Stack Overflow question and so forth. There's the sort of definition of the polynomial. There's this awesome file which I have only just read the introduction to, but it's another Australian from 1993 talking about everything you'd want to know about CRC algorithms. And so this looks really friendly, and unfortunately I just do tend to I've sort of sniped myself with this problem, and I kind of just wanted to solve it before I probably did enough research. So I intend to come back to this. And finally, there's CRC, as I said, is used in PNG. So one of the great things about this spec is that there's a sample implementation of this. And so here it is in C. So here they're making that table on the fly, sort of like how Zig was. And then they're going to basically calculate the CRC. So they're going to make the table on the fly if they need to, and then you can see it's just a very simple for loop. So I took this code, literally copied and pasted this bit here, and I was chatting to ChatGPT, and so I found ChatGPT pretty good. Like, I know there's other AI services out there, and ChatGPT might not be the best one anymore, but I do find its desktop app pretty convenient, and I found it good enough. I might switch to one of the other ones, but for now it's been good enough. And so I've just been asking it questions about the different standards of algorithms and so forth. But yeah, I pasted in this code snippet, and I asked it, have this algorithm in C, copied from the PNG reference, is there a way to write it where I don't need the lookup table? So it's just like, I'll just fire this off, It might tell me no, or it might generate code that's might trip over itself, but I thought, why not? And it helpfully said you can rewrite the algorithm in C using avoiding using the lookup table. And so here's the code. And so it took the existing code, and it probably knows a fair amount about different CRC algorithms, because it's a fairly popular algorithm. So I wouldn't be surprised if it's taken much more source than the code snippet I gave. But yeah, it implemented on the fly, and this is perfect for me because it's about a dozen lines of code and there's no lookup table to be seen. And so this is ideal. But there's like one little improvement I thought that could be made, which is it's doing a nested loop. And so that's going to do through the whole sequence of the string of bytes you're giving it. So that's it has to iterate through all of those. But it's going to do this thing here 8 times. And so I kind of know that like basic optimization, like I'm not an expert and I haven't even benchmarked this thing, but I kind of know, like, if you inline this loop, the CPU is probably going to be pretty happy. And like most C compilers are going to inline this for me, but because I'm writing my own compiler, I don't have that luxury. So the compiler is me, and I'm going to inline this. And so I've asked ChatGPT, can you unroll the inner loop? Just fairly high level question. Might have gotten confused about what the inner loop even was. It's this one here, and it completely got it. So this made me very happy, and it's changed that code over and just doing that operation that I was doing 8 times. So probably worth just a quick check. But yeah, it looks like looks good to me. So and so you can see here there's this sort of inner function, and then there's like a little bit of window dressing with this switching back and forth. But yeah, that's all the code I need. And so I then want to implement this in Orb. So C and WebAssembly match up very well. And so I took this code. It's not that complicated. And instead of asking ChatGPT to translate it, which I have done before. I just literally just pasted the code in or wrote it by hand here. And so in Orb, I define my WebAssembly function. So that's def w. It's going to take the pointer to the start of the string or array of bytes where I want to start, and then how many bytes I'm going to loop through. I'm going to loop through them all. I'm going to check that I'm within the bounds of where I'm looping. And then this is essentially that algorithm which I just translated. And so these XOR and shift right unsigned, these correspond to like raw WebAssembly instructions. So yeah, I was able to translate it pretty easily. Unfortunately, it's a very simple algorithm. But at this point in time, I've got literally no idea if this code works. Like ChatGPT could be dreaming. I could be dreaming. You know, do I know what I'm looking at here? Not exactly. Could be, you know, this thing could be completely wrong. And so, because I'm writing this thing in Elixir, one of the awesome things is I get access to XUnit. XUnit's a unit testing library, and it's just beautiful. It's just really nice. And also I get access to the whole Elixir and Erlang standard library. So if I look here, I just literally just threw this into my docs here. For the Erlang docs, if I type CRC, is there an implementation? And yes, there is. So Erlang's been around for 30 plus years, and it's one of those things where it is pretty batteries included. Ironically, it just added a JSON decoder and encoder, so it's a little bit maybe catching up there a little bit for some modern formats, but those sort of old classical formats, XML, MD5, as you can see here, like all this sort of stuff, it's got it. The batteries are included for it, so it's really, really nice. And so I'm very confident that its version of CRC is going to be battle tested and any bugs have been ironed out. And so I can just give it basically an array or technically a list of data, and it's going to calculate the checksum for me. So I can just give it like a string like hello, ask it to compute the checksum. It's just going to be like an integer at the other side. And so I found out what that was and then updated the test. And then I checked if my implementation from WebAssembly also had the expected output, and it did. So if I run these tests, they all pass. And so that's fantastic. That's, you know, I can compare a battle tested version to one that I literally concocted in ChatGPT, which I have quite low faith in being correct, and I validated that it worked. But that's only one value, so really you'll want to have many values and sort of check A/B test, almost check that the version from Erlang and the version that the algorithm I've just implemented is correct. So here I'm looping through literally like 1,000 different numbers, so from 1 to 1024, and this number could have been anything. And so I'm going to generate a array or list of those bytes that are n long. So it's going to be 1, and it's going to be 2, and it's going to be 3, and it's going to eventually be 1024 bytes. So that's going to come through, and I'm just being very lazy here, and I've called that A. I should really give some of these variables a bit of a better name, but that's going to come through. And so I'm going to say, hey, compute the checksum in Erlang, compute the checksum in mine, and they're exactly the same, right? Assert that is true. And that passes, and you can see it's like blazing fast. So that gives me very high confidence that this algorithm has been implemented correctly. There was one little catch that I caught. Initially this was 0 here, and I'll just bring the bug back. So this is one of the things with programming in a low level. When I was just giving an empty string, my version of the algorithm was incorrect. So it should be 0, but it's coming back with this number. And so I've made an explicit sort of little mini test for that, and I've ended up fixing it. Basically, when this length is 0, I need to bail out. Of this algorithm. Because I'm going to eagerly, this is sort of like a do while loop. I'm going to eagerly load the first offset here from memory. So that all works fantastically. So this is like pretty incredible to me that a few things here. One, I had this sort of algorithm I really wanted to implement, was able to implement it sort of in a half-wit style where I feel like as I said, I intend to do a bit more reading exactly on how CRCs work, but I was able to get an implementation with the help of ChatGPT and some research that I did as well. I think that's ChatGPT sort of works best where you sort of feed it some informed information rather than just sort of shooting blindly. And then I'm able to basically, almost like a scientific method, able to like lean on Erlang and its implementations of stuff and Elixir's implementation, and ensure that my implementation is correct. So yeah, this is a very smooth coding journey. So I was able to essentially open and close an issue in about an hour. So that's awesome. So if you're interested in knowing more about Orb, feel free to check out the repo. I'm slowly making more examples. You can run it in this really cool tool that Elixir has called Livebook. I'm slowly expanding the standard library for it called SilverOrb, and I'm going to create some more demos as well. And yeah, just feel free to play around with it. Let me know what you think. And I'm hoping that this can also, just like this file here with the PNG, I'm hoping over time that SilverOrb and the associated libraries can also be reference implementations. So I'm being sort of forced to, I've both chosen to go on this journey, but I'm being forced to have zero dependencies here, having to implement everything from scratch. So I'm hoping, this can be a helpful resource in the future for if someone else wants to implement CRC, they could come along and pick up my implementation. And I think one last note to show is that this Orb is obviously my language, but it compiles to WebAssembly, which is this. I think it's the new universal format like JSON. So it's this code here has been generated by Orb, and so I'm just going to select WebAssembly text. So yeah, here's the actual raw code that it generates. And so you can see it needs nothing else. And so this compiles down to something very lightweight. And so that results in a 2.5 kilobyte WebAssembly text file. But if I use the what to wasm command line tool, which converts from this text format into the actual .wasm, you can see here it generates a 333 byte file. So this code here that I just wrote, this algorithm here is 333 bytes. So I'm hoping both this WebAssembly text format and just the resulting WASM files can be resources for people in the future as well. Like this stuff's all open source. I want to sort of have no strings attached there. So let me know what you think, and if you have any suggestions for algorithms or problems that you think would be interesting for me to tackle, let me know.